distance vector routing DVR algorithm, and distance vector refer to the distance between the neighboring nodes. So vector means the state distance that is between the neighboring node. When we A to E distance is a vector. So routing refers to the established route which we take from traveling packets from A to B or A to C. That is a route. DVR is used to determine the shortest path for a network packet to reach its destination. So this algorithm helps us to find the shortest path so that the packets can be moved from one node to another node. Each router is designed to share vector data to each of its neighboring nodes in the network. So each and every node has a data about the neighbors, and it shared with all other nodes connected to it. Nodes share vector data at a regular interval in the network, and they have to share this at some interval, and there is some interval set so that after few seconds or few milliseconds they have to update its neighbors. Distance vector routing is based on the Bellman-Ford algorithm. So it uses Bellman-Ford algorithm for distance calculation, which is distance between x and y is equal to minimum of cost from x to node v, any versus you can say x to v, and then distance from v to y. So if we add these two costs, and there can be multiple path from A to C, like this path is there, this path is there, so we have to take the minimum. So dxy is distance from node x to v, and v is the neighbor of x, cost xv is the cost to reach the neighbor v, dvy is the distance from node v to y. So take the minimum from all the calculations. So how to do it is, so first of all we calculate the hop distance for node E. So there is a node E, we have to calculate the hop distance vector for node E. So we will check for all the other nodes which are connected to E. So there are three nodes, A is connected, B is connected, D is connected, so C is not connected. So we have to tell the cost, or you can say distance from the node E in hops. So E to A is one hop away, E to B is one hop away, and E to D is one hop away. So we have to just mention E to A is one hop away, E to B is also one hop, and E to C is not directly connected, so we will write infinite. Its distance is infinite. E to D is one hop away, and E to E is same node, so it's a 0. So this is the hop distance vector for node E. Similarly, we calculate hop distance vector for node C. So this is the node C. Two connected nodes are B and D. So its hop distance is 1. So we will write hop distance of A, because we are not able to reach from C to A directly. We can't reach C to A directly, so distance should be infinite. We can't reach C to E, so distance is infinite. So for A it's infinite, for E it's infinite. Otherwise C to C is 0, and C to B is 1, and C to D is 1. So C to C is no distance, 0 same node, C to B is 1, and C to D is 1. So this is the hop distance vector for node C. So we have calculated hop distance vector for C and E. Now we can calculate the routing table for node D, because all the connected nodes have their hop distance vector ready. So on the basis of these two hop distance vector, we can calculate the routing table for node D. So because it build a routing table from all its neighbor nodes. So we need the hop distance vector for node C and hop distance vector for node E. So D require C and E, information about C and E, and from these two tables we can calculate the hops away. So A is 2 hops away from D, that is this and this, 2 hops away, and it's via router, you can say E, so we can reach via E. B is 2 hops away and we can reach it through E, or you can reach it through C, so E or C. So both, we can use both E or C. Then C is 1 hop away, so it's through C, and D is the same node, so there is no need of any router. E is 1 hop away and it's through E. So this is the actual routing table of node D. So similarly, all the other nodes also build their routing table to send the data in the network. So there are also some problems like count to infinity problem is encountered in this problem. So why these two problems occur in this algorithm? So let's see this circuit in which we have in this network we have 3 nodes A, B and C, and if they are connected they can send data from A to B, then from B to C. Suppose at some time there is a link failure between B and C. If this link fails, then we won't be able to send data from B to C and C to B. But the routing tables already stored in A, B have the which shows that the A has a path for sending data to C in 2 hops. 1 hop is this, second hop is this. Okay, and B have a path to send data in 1 hop. So in case like this, in link failure, if B to C, BC link fails, this fails, then B to C link failure, what happens that as the link fails, B updates that B to C distance is infinite. BC distance has become infinite, means it can't send data. But A still thinks that there is a path from B to C because A has not been updated immediately. So it sends data to node B for a packet to node B for sending forwarding. So packet arrives here and B sees that there is no path. It asks A for is there any path to send data to C? It says yes, I have path to send data by 2 hops. So B sends that packet to A and updates its table that I have a path to send data to C by 3 hops, because first it has direct link, it knows that I can send data in 1 hop. Now it has asked A whether A is able to send data to B. A says that I can send in 2 hops. So it made it a 3 hop, 1 hop to send to A and 2 hops to send to C. So then again, if it sends that data to node A, and when it comes to A checks that if there is any path to send data to C. It sees that B has declared that it has path to send data in 3 hops. So I can send data to B and B will send it in 3 hops, and it makes the distance number of hops for 4. So then it sends data to B. B again asks if there is a path. Then it checks that it is possible to send data through A. So it makes that A can send data in 4 hops and I can send data to A in 1 hop. So total it makes 5. that B thinks that he can send data to C in 5 hops, and it send data to A. Again, A updates his table. It says that B can send data in 5 hops. I can send data to B in 1 hop. So total distance is 6 hop. So continuously they increase the hops 5, 6, 7. Then it makes it 8. Then it makes it 9, and it goes up to infinite. So that's count to infinity problem. And the data which is moving between these two nodes, if there are only two nodes, data is going to this node, then this node, then this node, then this node. It's just circulating in loop. So that these loops in the network are known as a routing loop problem. And the hop distance which is goes on increasing one by one up to infinity, that is called count to infinity problem. Thank you.